Hello, and welcome to the second episode of ADC Aspects. I'm Jeffrey Lawton, Product Marketer for Microchip Technologies Analog Division. In this episode, we'll discuss ADC linearity. When an ADC is nonlinear, it brings imprecision in measurements. Two important parameters are the differential and integral nonlinearity, or DNL and INL. In the first episode of ADC Aspects, we introduced the ideal transfer function and LSB. This will help us visualize DNL and INL. Ideally, any two adjacent digital codes correspond to input analog voltages that are exactly 1 LSB apart. DNL error is the measure of the maximum deviation between actual steps and the ideal steps. This can be observed on the ADC transfer function as uneven spacing of the code steps. The presented figure shows areas where the DNL error is -0.5 LSB and +0.5 LSB. It is important for the DNL error to be less than 1 LSB in magnitude to guarantee no missing codes. Missing codes are output digital codes that are not produced for any input voltage due to large DNL error. The figure on screen shows code 011 missing in such a case. Some datasheets, such as those for delta sigma converters, may not list a DNL specification, but will state whether or not the converter has no missing codes. INL is the integral of the DNL errors. Thus, the INL errors at any given point in an ADC transfer function is the accumulation of all previous DNL errors. INL describes the deviation the actual ADC transfer function is from the ideal straight line. It may be expressed in LSBs or as a percentage of the full scale range. It is also important to note that there are several ways to calculate INL. The INL can be specified by the code transition points, also known as loci transition, or through the code centers. Comparing the two figures, it can be seen the INL value will be somewhat smaller using the code center method. To add to the complexity, the ideal straight line can also be defined in different manners, either using the endpoint method or best fit method. For the endpoint method, the deviation is measured from the straight line that runs through the origin to the full scale point. This is the most useful INL measurement for precision measurements as it provides the worst case INL, which can be used for error budget calculations. For the best fit method, the ideal transfer curve is drawn as a close linear approximation to the actual transfer function of the ADC. Doing so incorporates the ADC's offset and gain errors and results in nearly a 50% lower INL value. So care must be taken when comparing datasheet specs. I hope this clears up the different definitions of DNL and INL you may come across. Thank you for joining me in this edition of ADC Aspects. For more information, visit microchip.com/dataconverters. I'll see you next time.